This video, we will see further problems from exercise 1.1. Question number 5. Justify the trueness of the statement, an element of a set can never be a subset of itself. So, let me take an illustration for you. Let's say you have a cartoon or a box where they have three t-shirts. You have a pink t-shirt here, a black t-shirt, and then a green t-shirt. Right. So these three are in one box. So we can call this a set A, which comprises of pink, black, and green t-shirts. Then let's call a set B, which actually symbolizes another small box which has only the pink t-shirt, and another set C, or a box that has only a black t-shirt. Then set D, or another box which has only green t-shirt. Now the company, for its purpose, would refer to box A, box B, box C, and box D. They will not call it as pink t-shirt, green t-shirt, black t-shirt, but they will number them as A, B, C, D. This is just for illustration that I'm trying to make you understand the concept behind sets. Now, we know that pink is a subset of the set A. Now, what do I mean by that? What it means is the set B, which has pink as the element of A, is a subset of A. So pink t-shirt is not the subset of A, but the set B, or the box which has the pink t-shirt, is a subset of A. Similarly, the black and the green t-shirt. I hope that's clear to you. So that's why this statement, which says an element of a set can never be a subset of itself, which means the element is not the subset, but the set B, which comprises of the element of A, is a subset of A, right? Hope that's clear. So let's just put that in writing. This you don't have to draw this picture for your examination. I will, put it in words to make you understand this. So let's define our set A. Let set A is equal to pink t-shirt, comma, black t-shirt, comma, green t-shirt. And set B is equal to pink t-shirt, and set C is equal to black t-shirt, and set D is equal to green t-shirt. We will explain it here as the pink t-shirt is not a subset of A, but the set B, which contains the pink t-shirt, is a subset of A. In other words, pink t-shirt belongs to A, and pink t-shirt belongs to B. Therefore, B is a subset of A. However, pink t-shirt is not subset of A. Therefore, the given statement which is an element of a set can never be a subset of itself is true and justified. Question number 6. If P of A is the power set of A, is equal to 1024, and N of A union B, which is the number of elements of A union B, is equal to 15, and N of power set of B is equal to 32, then find the N of A intersection B. All right, before we go into this, let's look into some formulae. So we know that N of the power set of A is equal to 2 power N, where N is the number of elements in set A. Well, when I say N, I'm referring to this N here. Right. So what we are given is given N of P of A is equal to 1024, which means if this should be equal to 2 power some value x, where x is the number of elements. So 2 power what will give you 1024 is 2 power of 10. Therefore, N of A, the number of elements of A, will be equal to this 10 here. So that is 10. So we have N of A. Next, let's find N of B. So given to us, N of P of B is equal to 32. So let's call this as 2 power y. So which will be equal to 2 to the power 5. Therefore, N of B is equal to 5. Next, we need to find N of A intersection B, and we are given N of A union B. So again, let's use the formula. Let's say we know that N of A union B is equal to N of A plus N of B minus N of A intersection B. We know this formula already. So let's apply all the values here. So we know that N of A union B is 15. So 15, so this implies 15 is equal to 10 plus 5 minus N of A intersection B. So solving this, you can say 15 is equal to 15 minus N of A intersection B. So we can clearly say that N of A intersection B is equal to 0. That's the answer. Question number 7. We're given N of A intersection B equal to 3, and on N of A union B is equal to 10. We have to find N of the power set of A symmetric difference with B. Now, A symmetric difference with B is given by the formula, or rather N. The number of elements of N of A symmetric difference with B is equal to N of A union B minus N of A intersection B. So these numbers are available to us. So replacing them, A union B is 10 and A intersection B is 3. So that's equal to 7. Therefore, n of the power set of A symmetric difference with B will be equal to 2 to the power number of elements of A symmetric difference with B. So number of elements of A symmetric difference with B is 7. So 2 to the power 7. And that is equal to 128. Question number 8. For a set A Cartesian product with A contains 16 elements and 2 of its elements are 1, 3 and 0, 2. Find the elements of A. So what is given is that A Cartesian product with A has 16 elements. Now this is possible only if A or n of A is equal to 4. Or I can say therefore since 4 by 4 is equal to 16. So if A has 4 elements, then each of them will be like 4 elements. So the Cartesian product would be, just to explain to you what's a Cartesian product, let's just this is just for your understanding. Let's say A is equal to A1, A2, A3 and A4. So A Cartesian product with A will be A1, A1, then A1, A2, A1, A3, A1, A4. Similarly, it will be A2, A1, and so on, all the way to A4, A4. So you can clearly see there are 16 elements. So you need to have equal elements for it to make it a 16. It should be equal to 4 by 4. So we have now that our n of A is equal to 4 elements. So if we have 1, 3 as one of the Cartesian products here and 0, 2 as another Cartesian product, so then 1 and 0 are elements of A and 3 and 2 are also elements of A. That makes it 4 elements. Therefore, A is equal to 0, 1, 2, 3. This is 0. Question number 9. Let A and B be two sets such that n of A is equal to 3 and n of B is equal to 2. So if x1, y2, z1 are in A Cartesian product with B, then find A and B where x, y, z are distinct elements. So what is given to us is that n of A, the set A, is equal to 3 and n of the set B, which is the number of elements in set B, is 2. Then we are also given that A Cartesian product with B comprises of x1, y2 and z3 along with the other elements in the Cartesian product. Now what would this mean? A Cartesian product is an ordered pair, which means, let's say that A comma B belongs to A Cartesian product with B, where A belongs to the set A and B belongs to the set B, which means the first element here, A, will belong to A. Why? Because the Cartesian product is in the form A Cartesian product with B. So from this we can say A, the element A will have x, y, and z, which are the first element of the ordered pair. And since n of a is equal to 3, x, y, z are the elements of A. Similarly, for B, from this we can say 1, 2, it's z and a 1, not z and a 3. Let me just correct it. So we can see that 1, 2, and 1, these are the elements that we are seeing here from set B. So 1 and 2 are the elements of set B. Question number 10. If A Cartesian product with A has 16 elements, now we know that A and A will have equal elements in the same set. So its Cartesian product has 16 elements, which means it must be 4 by 4. Anyway, let's read the question. So S, the set S is equal to set of all A comma B such that A comma B belongs to the Cartesian product of A, Cartesian product with A, and also A is less than B. And you're given two elements, which is -1 and 2, and 0 and 1, or two elements of S. Then find the remaining elements of the set. So from this we can clearly say that A is equal to, since n of A, let's put n of A is equal to 4, since A, Cartesian product with A, has 16 elements. Okay, therefore A is equal to, from here we can say it is 0, 1, -1, and 2. So the remaining elements of the Cartesian product, or let's find the Cartesian product of A with A, will be 0, 1, 0, -1, 0, 2, and we'll also have 0, 0. Then it will have 1, 1, 1, 0, 1, -1, 1, 2. Then it will be -1, 0, -1, 1, -1, -1, -1, 2, 2 and 0, 2 and 1, 2 and -1, and 2 and 2. That will be the full set of Cartesian products. Now S is a set of all elements A comma B which belongs to Cartesian product A with A, and A is less than B. You're already given two elements which belong to this. So let's mark those, which is -1, 2, and then 0 and 1. Now let's try and find the other elements. So if we have to say set S, already given to us that 0, 1, -1, and 2 belong to S. Now let's mark the other elements which satisfy the conditions A less than B. 0 is not less than -1, so this is not. 0 is less than 2, so this belongs to the set S. Then you have 1 and 2, which will belong to the set S. -1, 0 will belong to the set S. -1 and 1 will belong to the set S. So you have four elements, which are 0, 2, 1, 2, -1, 0, and -1 and 1. Therefore, the other elements of the set S are, let's write them down, 0, 2, 1, 2, -1, 0, -1, and 1.
Thank you for watching Math Tutorial Anand. Please like, and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.